Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good, so last session we did work on the frame pacing, frame limiting. Yeah, but there was some issue. Okay. Okay, before we get back to code, let me see if there is some action item that we should maybe look into. There's quite a number of things here. Oof. Mark this is done. What is this? Search and destroy affects detection range only when it is omitted in the stealth detector update, since it defaults to vision range which search and destroy extends. Explicitly setting it breaks this. Independent balancing. I'm not surprised about bugs on some units. Detection range only when it is omitted in the stealth detector update. I don't understand this report. It sounds like a bug, but I don't quite understand. Maybe someone does. Probably need to look into this detection range thing, what that means. Dustin, enable this. He never did. Oh. That's unfortunate. This change brings a small performance boost and logic optimization in the do circle fill method, which is a process used to determine which cells of the grid a medium to large cylindrical or spherical object occupies. The original implementation is incorrect in that it used a fixed cell radius in the loop condition instead of the decreasing y value. This means that the circle fill is not only performing redundant iterations on repeated rows, but also erroneously filling trapezoidal, what does that mean? Trapezoidal shapes along the top and bottom of the circle as the axis not being curved along each scan line. Cells occupy 40 by 40 world units. The shapes do not cover any additional cells as no object geometry is a large enough radius to be affected, which identical cell coverage at radius of 230, which with identical cell coverage. Okay. The largest circular geometry in the game is the anthrax bomb poison field with a radius of 150. Regardless, the fixed logic is behind a retail compatible CSC flag to guarantee no mods or maps that introduce gigantic geometries cause any mismatch due to different cell coverage. See below for comparison. Demonstration of the trapezoidal issue. Original fix. Tabulated differences. Loops, total number of for loops iterations, including nested scan line iterations. Okay, let me take a look at the oh, well, it's a small change. uh, let's see. Do circle fill. Cell radius. X smaller equal Y. X smaller equal Y. Hmm. 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 Okay, it's the same. Y is the same as cell radius. Huh? Oh. It decrements it here. Uh-huh. Hmm. Mm-hmm. 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 Okay. Okay, how do we read this? Tabulated difference. Loops version 1. What does this version 1 mean? What is this? Does it mean the original one? Probably. Radius. Okay, so I assume that this means the original one and loops version 2 is his edits, right? Okay, so radius, let's say here 201. So that's a bit faster. Okay. So there's some gain here and there's also some gain here. And cells. Divergent cell coverage. Ah. Okay. Okay, so he says that it improves the performance noticeably. Mm-hmm. And it only changes behavior when it's larger than this radius of 240. But he says that there's no thing that is larger than the anthrax bomb with a radius of 150 in the retail game, so it doesn't affect gameplay. Okay. Fix redundant cell checks for large. Okay. I understand the proposal. I understand what he explains here. Yes. I don't yet understand the exact implementation. So what does this do? Do circle fill. Center X, center Y. Okay, so this is some dot somewhere and a radius. Okay, fair enough. Then word to cell. Okay, then it gets an integer, cell, x and y. Okay, so this is like a grid on the terrain, I guess. Yeah. And then cell radius is... Okay, so cell radius is... H-line circle. Decrement plus y. Okay, this code is really hard to understand. For me, it's hard to understand. I don't even know what this H-line circle is. Let me open this thing and let me put a bookmark here. What is this H-line circle? Oof. Add subpix to coverage. Okay. I mean, so to me, it looks like an innocent change. I don't see anything particularly wrong with it. I also don't understand like how exactly this works and how it fixes this, but like visually it's fine, right? So instead of going to cell radius, it will iterate towards y, and this will decrement here, so the loop will be much shorter than what it was before, because here cell radius is like something that doesn't change, but y is decreasing. Yeah, so I certainly see how this improves performance. How it exactly fixes the shape issue, I don't quite follow. But apparently the shape looks like this otherwise. Yeah. Okay, so this will be bug performance. Is this for both games or just 0 hour? Oh. It's both generals and 0 hour. Gem ZH. To do replicate in generals. Nice illustration. I don't quite. I understand. I understand the problem and implication, but do not quite follow the algorithm. How did you find that? How did you notice? Yeah, I'm surprised how he found that. I would have just glanced over this code because it's really not obvious that this is broken. It's really not obvious to me, at least. Maybe someone knows this algorithm and oh yeah, easy peasy. For me, it's not obvious at all. Yeah, this is quite some intricate logic here, which would have been nice if there was like some explanation. Yeah, it's probably from some textbook. The algorithm. I don't know this algorithm. Maybe you can probably ask AI, hey, please explain me this algorithm here. Yeah, probably can do that. Okay, well, it looks promising. Also, let me ask. Oops. Also, how big of an impact does this have in a busy frame? Is it a minor or major performance improvement? Okay, let me get back to code. Good. So last session we looked at the FPS, right? Good. So we did have problem. We did have a problem with a frame rate when we did have a problem with the frame rate when we have 60 render frames, 60 FPS rendering and 30 FPS logic frame, right? Somehow there was at the start of the game, let me look at this one more time. At the start of the game, the dozer and the world, everything would move fast. And then only Yeah, so now you see the dozer is far, now it slows down suddenly. Why does this happen? That I don't understand. How does that happen? It's a really interesting issue. Yeah, so for like 2 seconds, the dozer drives fast and then it drives normal. That is so weird. How does this happen? How does this happen? This value doesn't change. This is always the same here. We add the frame time. We don't reset this thing. Aha. 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 Yeah. Yeah. We don't reset it. Huh. That's a problem. Render limit. Where do we reset it? In reset. Yeah. Yeah. Maybe. But is that really the issue? And the value should always be rather low. Let's try it. It doesn't hurt to reset here. Yeah. Let's just put it here at the bottom. I think we can initialize it with 0. Yeah. And we can also initialize this with 0. Oops. Okay, but that's also, I don't think that's a reason. No. Because actually, I don't know. Let's see. I don't expect that this will fix anything. No. It doesn't. is the problem? It's probably a super stupid reason, but I don't see it right now. Why does this happen? We add the frame time here. Could it be that we accumulate the no, the frame time should always be low here. Boah, that is weird. Why does this happen? The logic frame time, yeah, the algorithm here is fine. It looks perfectly fine to me. Yeah, we only attack the logic frame if we are past the target frame time, and then we deduct this. Done. Yeah. This is a float. This is a float. Yeah. This is an integer. Plus frame time. Logic frame plus frame time. But once it corrected itself, it looks perfectly fine. Looks super smooth. Yeah. If it would always be like this, that would be fantastic. Why is it wrong the first few seconds in the match? I don't understand. It's so weird. It really is super weird. There's not much here, but it is there. How do we fix that? Wow. How do we fix that? Okay, so I put a breakpoint here and just step through it. Target frame rate is 0.33, yeah. Now next frame. Frame time 15. And we do have this, yeah. If this is larger. So if this number for a long time is long, if you have like long stalls. Now I understand. If you start a new game, you will have some long stalls at the beginning, which then add really long frame times to this counter. So it will charge up a large number. Right? That's a problem. So maybe we need to set it to 0 in here. Yeah. Maybe we don't decrement, but we set it to 0. We have to, otherwise those big stalls are killing us. Let's see how this feels then. But with this, I feel like we need an epsilon with this. Yeah. Anyway, let's see how that looks. I think that will fix this issue with the fast movement at the start, but it may introduce other issues. Looks okay. Looks pretty smooth. There was some stall there. Some hiccups. Okay, let's see if we put a breakpoint here. Yeah, so there's some up here. How about I think there is a benefit if there's what we can do is we can maybe put an epsilon here. So we say here minus some minus, I don't know, 0.0. Maybe we do a fraction of the target frame time minus target frame time. So let's do a const real epsilon is I don't know, divided by 30. So how much would that be? Let me open my calculator. Maybe we take this value. So that would be 0.0333 and then divided by 30. So the epsilon would be that, which sounds okay. Basically, we want to protect ourselves against some minor frame dips, which are very natural, right? Maybe we can have a larger epsilon. Maybe this divided by we divide it by the half of this guy. So 0.0333 divided by 15. That's 2.2 milliseconds. So basically a frame drop of 2 milliseconds and would still pass, which sounds reasonable. Yeah. So maybe take this epsilon. Let's test this a bit. Can optimize this with time 0.5 here. Okay, let's put a breakpoint and see how that fares. about the same. Not much difference. We still have 166 here. If this was 0, then we would be on the safe side, but it's not rising much though. It plays pretty well, but I need to. We still need to be careful here. It seems fine. So there is a risk that if we have unstable frame rates, that it could act in weird ways. Stable frame rate, it seems pretty okay. Yeah. There's some here where it goes here, but at least there's nothing here in the third bucket, so that's good. Okay, how about we test this with unlimited frame rates? Yeah, play game. Let's build some things here. Let's put a breakpoints. Now there's a larger distribution of things because the frame rate is fluctuating more. Okay, let me get into some game where we can even have higher frame rates. I think we are approaching crash territory here though, with high frame rates. Maybe we need to have a larger buffer. Let me make this 100 here. $100 means we can go to 900 FPS. 30 times 100, 3000 FPS. Yeah, I think. Wrong map. Let me load the map where there's nothing going on here. Okay, frame rate. We are currently running in debug. How about we compile and release so we get high speed? High speed, please. Release. There we go. Does it need to be replicated in general? It's, probably not. Zero ratio. Hold on. Okay, so now we have 300 FPS, and those are drives normal. It looks pretty smooth to me. All the armies come at once. That's funny. That's great. Uh, okay. Yeah. So it's on high frame rate. It looks really fine. Yeah. Okay. Let me go once more to low frame rates, to 30 FPS, maybe even 15. Huh. Okay. Let's do 30. 30. Play game. Let me actually restart the game so we get a clean clean debug history here. It looks fine. Let's put a breakpoint here. So they are mostly here. There's one here. Longer, interestingly. Huh. How did that happen? I'm surprised by this one here on the second bucket. Huh. How did that happen? No idea. Okay, let's test again without the epsilon. I'm still not sure if we need that epsilon. It could help. Oh, hold on. What happened? Ah, there's a compiler error because of this. Oh, I didn't mean to have a breakpoint here. Okay, let's build some instant here. Low power. Oh, now we will build so slow. Okay. This looks fine. Okay, so if we now check this debug counter here, what does it say? Looks perfectly fine. So the epsilon is not really needed here in this case. But that's only because it's stable. If it wasn't stable, we need the epsilon. So I have the feeling that the epsilon is beneficial. But how do we prove that? I don't know. 2 milliseconds. 2 milliseconds for I have the feeling that this epsilon is maybe too large. Because let's say a render frame would be less than 2 frames. How much FPS would there be? How do we get that to FPS? 1 divided by this number? 450 FPS. 450 FPS, and then we would have a frame time of 2.2 milliseconds, which is not unrealistic. No. Really so fast? Divided by 450, yeah, 2.2 milliseconds. That's pretty fast. That's certainly in the realms of possible. And in that case, the frames would actually be too fast. Yeah, okay, that's not good. The epsilon is too large. It's too large. The epsilon, the max frame rate is 1000, right? So maybe we say 1000. We can put there was some place where here there's a cap 1000. Maybe we just make the epsilon smaller, so could divide it by 4 maybe. So make it half of that, divided by 2. So that's 1 divided by that. It's 900 FPS. It's pretty fast. Maybe we make the no. So target frame time, so that's 0.0333 divided by 30, which is that number. Okay, how about we do times 2? So it's 0.033 divided by that was 30, so times 2, 60. Now that's pretty low, isn't it? And we do 1 divided by that number, and that's 18,000. 1800 FPS. Yeah, maybe that's a good enough threshold. So we don't divide by 2, but we multiply by 2. Small epsilon to accounts for mini frame dips. Let's add this comment here. Yeah. deduct a small epsilon from the target frame time to account for mini frame dips. To counter for many frame dips. Okay, super hackers at tweak 080608 gates puts puts a single player logic updates, puts a single player logic update behind a logic frame cap to decouple the frame rates, the render frame rates from the simulation frame rates, from the game simulation frame rates. Okay. I think that epsilon makes sense. A bones, I think it doesn't have much of an impact really. Yeah, I think to me it looks fine. Yeah, maybe it is a bit too small. I mean, we could make it a bit larger like this. Let's say would overshoot at 900 FPS with epsilon would overshoot. Render FPS. Let me confirm that once more. So this target frame rate is 0.3 0.0333 divided by 30. That's that. And this number 1 divided by that is 900 FPS. Yeah. Yeah. I think that's fine. I think this is okay. Okay, let's clean up our implementation. I think we can revert this one. Ah, shit, no, we can't. We can't. We need to return Rio here. Yes. But we can revert all this here. I think we can also remove this guy here. Why is this not found? What is this? Why do we not find this? There it is. Leave a space here. Okay, I think we can revert this one and this one. And this. And this. And this. Let's move these guys here. this is last frame, last render frame time. Logic, frame time. I think we should rename this to something else. It doesn't do the same as this one here. Logic, frame time. Accumulator. Frame time accumulated towards submitting a new logic frame. What we should probably also do is add a function here for set logic FPS. I don't know why it has to be this long here. So logic FPS, get logic FPS. Why are these so far apart here? What is this? What? Why is this somewhere a completely different location here? What is this? Huh? Set frames per second. No, this is max logic FPS and return max logic FPS. Okay, so we have functions to control this. Doesn't necessarily mean we hook it up yet to anything. There's another thing that we can do. Execute. There's one more thing we can do in the update function. We can say if the max FPS is identical to the max logical FPS, then we don't need to do this calculation here. Then we skip that and we go directly into the update. So here we can say if max logic FPS is identical to M max FPS, then we simply call this else. Doesn't need an extra comment, I would say. Yeah, because I mean, if the max FPS and the max logic FPS is the same, then we just couple them together. There's no need to do any calculation then, right? Yeah. It's only if they're different. Actually, also only if if max is larger, if it's smaller equal max FPS. No. If it's larger equal. Yeah. If it's larger equal max FPS. Because if the render frame rate is 15 and the simulation is 30, then we are bound by the render frame rates. Then we don't need to go through here either. It's only when the render frame rate is faster than the logic frame rate, then we have to wait here or skip, let's say. And here in network, it's completely different. Let's add a comment here. Logic is smaller equal larger equal. Logic FPS is larger equal render FPS. Just updates straight away. Yeah. Okay, then we can also revert this one here. Let's test replay. Well, we don't really have a good replay right now, I guess. Yeah, the problem is it won't play back nice. Because this replay is mismatching with this game version. Well, it's okay. It's good enough to look at. So we have 30 FPS now. We need something else. We need to also be able to enable and disable. Yeah. Let's add a bool. Enable logic FPS limits. Or let's say cap logic FPS. Then here we add another function, voids cap logic FPS bool cap. Not sure bool is logic FPS capped. Why do we do this? Yeah. Okay, cap logic FPS, and then that will be cap logic FPS equals cap. Return cap logic FPS. Yeah, FPS. Maybe write it like so. FPS. This const. Good. Okay, and then if and then we say here, if that's, if not is capped, or that. Okay, that means we can also opt out of this capping. Okay, cool. Okay, I think in game engine we have everything in place to make this properly work. Now what we need next is controls to actually control it from player, right? Otherwise, yeah, you cannot use it. This one needs to be initialized to false probably, right? By default is off. Yeah. Let's do a bool cap equals is logic FPS capped. I'm doing this so that it would be possible to overload these things. Not that anyone would want these, but these are virtual functions, so I think it makes sense to write it like this. And then we use this here, and this here, and the max here. also do max FPS. And max FPS equals get oh, we made a mistake here. Get frame rates per second limit. There we go. It looks good to me. Let's make a change. Is it a feature or is it tweak? Tweak. Tweak FPS. Decouple logic frame rates from render frame rates. We should probably also add some description here. The default max render FPS effects. I think that needs. I would just leave it. What about in game data? Game data. No, that's global data. There we go. FPS. FPS. Frames per second limit here, this one. Why is this set to 30,000 here? Ugh. Good. We have no updates here. That's interesting. It's very quiet. Okay, let me see what we currently have. Oh boy. What we currently have ready for submission. I think I will merge this one here. It's pretty big. Yeah. It touches 78,000 lines. Okay, here goes nothing. There we go. Now we should also be able to merge the editor config. Okay, let me go to main branch. Oof. Just once more. Good. I think that was a very successful session. The frame rate thing works very well. I'm surprised. Very nice. Okay, then what we need to implement next, we need to have a key mapping to toggle the logic FPS limit on and off. I don't think we need yet a key mapping to like toggle the value of this limit. Like I think it's fine if it stays at just 30 and you can't change that in the game. In theory, it would be possible. Like let's say set it to 60, right? And then everything would move twice as fast, right? With uncapped FPS. So you could do that. But I think for starters, it would be enough. We need a button mapping for actually we need 4 button mappings. Increase render frame rate, decrease render frame rate, increase logic frame rate, and decrease logic frame rate. And with these, you can cover all the states. You can jump to certain like levels of frame rates, and then when you reach 0, you uncap. Yeah, when you reach 0, you uncap. Yeah. You could do that. Yeah. Good. Worry about this next session. Okay. Good. Then that will be it. I wish you a great day or night. Until next time. Goodbye.